Today we'll discuss a chapter that is extremely important for JEE and NEET and very rarely stressed by students, but this chapter is also very easily understandable, but many of you do not have very solid foundation on this chapter. So that easy chapter, easy to be understood but rarely stressed, is the chapter of relativity. So let's go for it. So relative velocity was defined like this. So this is say VAB bar. So what is VAB bar? It is the relative velocity of particle A with respect to particle B. This is the definition of this. And this is the Galilean relativity equation. But basically, as we all know, that who discovered first the concept of relativity? That was Einstein. So what is the Einstein's equation? So this equation that you are seeing, which is the Galilean relativity equation, it is basically a special case of Einstein's theory of relativity equation. So I'll first give you Einstein's relativity equation and then you can easily understand that how this equation is coming. So it is like this. So suppose if particle A is moving, say in this direction with some velocity VA bar, and say here another particle B is moving with certain velocity VB bar. So by Einstein's theory of relativity, the relative velocity of particle A with respect to particle B is given by this equation, by this famous equation. This equation is velocity of particle A minus velocity of particle B divided by 1 minus VA bar dot VB bar whole divided by C square. So the relative velocity that we are going to discuss in our syllabus will obviously have velocities of the particles VA bar and VB bar much lesser than the velocity of light. So here the denominator is very large, it is C square. So obviously denominator is so high that this fraction will become 0. Number 0, it is 1 minus 0. So VAB bar now becomes VA bar minus VB bar. This is the Galilean relative velocity. Now let us try to understand the Galilean relative velocity that is included in our syllabus by some concepts and some numerical. Okay, let's go for it. So first of all, velocity of particle A with respect to particle B is, what is the equation? VA bar minus VB bar. Now how this equation is coming? So for this equation to come, you remember the concept that I have told you in the last video also, that displacement is basically what? It is the coordinate, and coordinate makes which concept? Coordinate in a vector. If you relate coordinates with vector, which concept you get? It is the position vector concept. So suppose if this is an coordinate axis system x, y and say here z. Now here suppose a particle A is there with displacement which is position vector SA bar, and here you have another particle B which has position vector SB bar. So this is SB bar. Now from triangle law, I think you can easily understand that what will be this displacement. So this means that if SB bar is added with this second vector, you get SA bar. So what should be this vector? So by triangle law, I can easily write this vector is going to be SA bar minus SB bar. So this is the position of particle A with respect to particle B. So what B is seeing, where A is there with respect to B, this is the position vector or the displacement. So change in position vector is the displacement. So I hope you have understood this. And this is equal to what? The position of particle A as seen by particle B. So this I will write what? SAB bar, right? So this is easily understood. Now, if I take a derivative of this with respect to time, so I am taking derivative of this equation with respect to time. So what I am getting? I am getting dSA bar dt minus dSB bar dt, which is equal to ddt of SAB bar. But this one, the rate of change of displacement with respect to time is velocity. So this is going to give me what? This is going to give me velocity of particle A with respect to B is equal to velocity of particle A minus velocity of particle B. So this is the concept of relative velocity, and this is the proof of this equation. Now once I have proved that equation, I can also write what is the velocity of particle B with respect to particle A. Obviously, with the similar funda, it will be VB bar minus VA bar. And what we proved beforehand, it was velocity of particle A with respect to B, whose equation was velocity of A bar minus velocity of B bar. So now if I add this, so what happens? See, plus VB bar minus VB bar cancels out, plus VA bar minus VA bar cancels out. So right side we get what? Not 0, it is vector, so we'll get VAB, it is 0 bar. So on the right side we get null vector or 0 bar. And if we add the left hand side, what we are getting? Velocity of particle A with respect to B plus velocity of particle B with respect to A gives us a null vector. So when the summation of two vectors is a null vector, the vectors are negative vectors. So this means relative velocity of particle A with respect to B, here B is the observer, relative velocity of particle B with respect to particle A, here A is the observer, the summation will always be null vector. That means suppose if one relative velocity say is along x-axis, suppose assume VAB bar is along x-axis. So what should be the direction of VBA bar? You tell me. It is going to be equal in magnitude but opposite in direction. That means the relative velocity of particle B with respect to A must be along negative x-axis. And suppose assume that this is 5 I cap. So the value is 5. So this is going to be how much? It is going to be 5, but because it is along negative x-axis, so it is going to be minus 5 I cap. I hope it is clear. So what I am going to do, that I am going to solve one question and let us try to understand the equations much more better with the solution. Okay. So the question says that suppose there is a boat which is going along x-axis with a velocity u, and there is another boat which is going in this direction making an angle theta with velocity 2u. So this is the velocity of the boat B. Okay, and this is the velocity of boat A. Now if boat B is observed from boat A, so suppose somebody in the boat A observes boat B, what he is going to observe? He is going to observe the relative velocity of boat B with respect to A, right? This is what he is going to observe, VBA bar. This is the velocity of boat B with respect to boat A. So the question says that this relative velocity, that means the observed velocity by someone on the boat A is along northeast. Now what is northeast? This is the east direction. This is the north direction. Northeast is the direction which makes an angle 45 degree. So this means the question is saying that the velocity of the boat B with respect to boat A will be in this direction. This is a 45 degree angle. Okay. So what is the definition of this? We already know VBA bar is equal to VB bar minus VA bar. So what is the direction of the boat A? Initially it is along east, towards east this boat is going. So I have to take a subtraction of this, the negative vector of this. So this is a minus VA bar, right? Now according to the question, this minus VA bar and the VB bar, see VB bar minus VA bar, this means basically what? This means basically the velocity of boat B plus of minus VA bar. So it is the resultant of negative of velocity of boat A and that of velocity of boat B. So this is the velocity of boat B and this is the negative of the velocity of A. So these two velocities resultant is going to be along the 45 degree angle or along northeast. Obviously my diagram is not scaled properly, so I'll little bit erase and I'll try to draw it properly. So the resultant of VB bar and minus VA bar. So minus VA bar will be in this direction. I think this is a little bit long, so we'll just scale the diagram. So the parallelogram will be something like this. Okay, so this is the velocity of boat B with respect to A. And what is the magnitude of this? This is the minus VA bar. So this is obviously minus U. But what is the mod? The mod is the magnitude of this length. The length of this arrow is going to be U. So this angle is given 45 degree. So if the resultant makes an angle 45 degree with east or along x-axis with respect to x-axis, so what will be this angle? This angle is going to be 135 degree, right? Because this is 45. So this means this is going to be 135. So now I'm going to use the formula tan alpha. Remember, if there is a vector a bar and there is another vector b bar, and these two vectors have an angle theta between them, and if this is their resultant, so resultant makes an angle alpha. What is the formula of this alpha? The formula of this alpha, tan alpha, is equal to b sine theta whole divided by a plus b cos theta, right? That is the resultant formula. So now here, what is theta? What is the angle between the two vectors whose resultant is VBA? So the resultant of VBA, this resultant is the resultant of this vector VB bar and minus VA bar. So this means this VB, this 2u is basically what? It is the B. So 2u sine theta. What is theta? Theta is the angle between A bar and B bar. So here it is this vector and this vector. So what is the angle between these two vectors? If this angle is theta, that means this total angle is going to be how much? Is going to be pi minus theta. So 2u sine theta, it is going to be sine pi minus theta divided by what? Divided by A. A is this. Now A here is the magnitude, not the vector. So the vector is minus VA bar, but the magnitude of minus VA will be u. So write u plus B. B is how much? 2u, the magnitude, into cos of theta. What is theta? Theta is cos pi minus theta. Now from the diagram, what is this alpha? The alpha is the angle made by the resultant with A vector. So the resultant is VBA. How much angle this VBA is making with this A vector, the minus VA bar? It is making how much? This angle is 45, so this angle will be 135. So this must be equal to how much? This must be equal to tan 135 degree. So I just have to solve this equation and that's it. I'll get the value of theta. So let us try to solve this. So I'll just erase all these things. Now what is tan 135? Tan 135 degree is minus 1, right? Cancel the u. Sin pi minus theta is how much? It is sin theta. So we get 2 sin theta. Cancelling u, here we get 1. Cos 180 minus theta is minus cos theta. So we are getting minus 2 cos theta. So just this simple trigonometry. So multiply this, you get minus 1 and this comes as 2 cos theta is equal to 2 sin theta. Target is theta. So do the side change. What we are getting for this? We are getting from here, if I take 2 out, 2 common, it is coming cos theta minus sin theta is equal to minus 1 goes on the right hand side. So this becomes 1. So you can take these 2 out here on the RHS and this becomes half. So basically now cos theta minus sin theta is equal to half. Cos theta minus sin theta is equal to half. This equation I have to solve. Now how to solve this? So what I am going to do is that I will square it. So if I square it, cos square theta plus sin square theta, so a square plus b square, so this will become cos square theta plus sin square theta minus 2 sin theta into cos theta is equal to how much? It is equal to 1 by 4, right? Half square. But this term is 1. So what we are getting, and this is 2 sin theta cos theta is sin 2 theta. So I can write, I'll erase this part. So what I can write is that sin 2 theta, this is sin 2 theta, do the side change. So sin 2 theta is equal to 1 minus 1 by 4. So this is coming 3 by 4. So 2 theta is sin inverse 3 by 4. So what is the value of theta? So the value of theta is half into sin inverse 3 by 4. So this is the angle the board B must make with board A so that the relative velocity of board B as seen from any observer on board A will be along northeast direction. So I hope this question is a good question. This is a good concept building question and I hope that you have understood the solution and you really like the question also. Now what is the application of relative velocity? Now the first application of relative velocity is the river crossing. So when a swimmer swims in still water, that means he is swimming, say, on the swimming pool. So what will be its velocity? Because swimming is done with respect to water. With respect to water, you are going ahead. So still water velocity of the swimmer we'll take it as VMW. Here the man is swimming with respect to water. And the river water velocity will be taken as VW. Remember, the velocity is defined Vm. If I say Vm, basically Vm means what? It is the velocity of the swimmer with respect to ground. So Vm bar is the velocity of man with respect to the ground. Here ground is at rest. So please do remember, this is where the maximum students make the mistake. VMW bar is what? It is the relative velocity of man with respect to water. It is very easily understandable, but what it is basically? It is basically the velocity of the swimmer in still water. So when the water is at rest, that means suppose if the swimmer is swimming in a swimming pool, then his or her velocity, that will be taken as VMW. So here we are seeing the river from the bird's eye view, that means aerial view, from the top view. And this is the river width D. And the swimmer starts swimming, say from this bank, river bank, and he is swimming at an angle theta. So this is the VMW. So if it is swimming pool, he will also swim in this direction. If it is river, he will also swim in this direction. Now my assumption is that the left side is upstream and the right side is downstream. Now use the Galilean relativity equation. So VMW bar is what? It is the Vm bar minus VW bar. VW bar is velocity of the water, river water with respect to ground, right? So now do the side change. Take minus VW bar on the left hand side. So what you are getting? Velocity of water, river water plus still water velocity of the swimmer is the net velocity of the swimmer. This is the velocity with respect to ground. That means those who are on the ground, so suppose if you have a drone flying above, the drone will see the swimmer swimming along which direction out of these three vectors. The drone will see the swimmer is going in this direction. So here it is VMW, and suppose here is VW. So upstream to downstream, the water is going in this direction. So now you have two ways to solve this question. The first way is that you go for parallelogram law. So these two vectors origin coincide, apply the resultant. So what will be the resultant of VMW and VW? We can easily see the diagonal. So the swimmer is going to swim in this direction, in the VM direction. Another thing is that instead of the parallelogram law, you go for triangle law. It is basically the same thing. Take the VW bar vector here and apply, and you are going to get the same answer. But my recommendation to you is that instead of going for the triangle law or the parallelogram law, it is better that you go for components. So first thing, do one thing that, and this is something that we always do for any kinematics motion, that whenever, where you should take the origin. The origin should be taken where the motion starts. So the swimmer has started swimming from this point. So this point will be taken as origin. The right side is the x-axis and the other bank side, this line is the y-axis, right? So what is the component of this VMW? So let me just erase this part so that I can make the diagram a bit clear for you. So the swimmer is swimming in this direction. This is the river water velocity at an angle theta with respect to the river bank. So what is the net x-axis velocity? The net x-axis velocity is VMW cos theta plus VW, because the water velocity will also get added along x-axis because the water is flowing along x-axis. What is the y-axis velocity? The y-axis velocity of the swimmer is VMW sine theta. Now wherever this swimmer reaches, say the swimmer reaches here some point A. Wherever this swimmer reaches, that point will have an x coordinate and y coordinate, right? And remember, coordinates are the displacement. So suppose if this swimmer reaches here at this point, say at point A. So the point A has a coordinate x, and what is the y coordinate? Because this is a bank which is parallel to x-axis, that means y is constant. So what is the y? The d. So this means this length is going to be d. So along y-axis, when the swimmer reaches the other bank, how much is the displacement? The y coordinate, the d. What is his velocity along the y-axis? The component of VMW, which is VMW sine theta. So what is the time the swimmer has taken to swim along y-axis. The displacement is d and the velocity is vmw sine theta. So what I'm going to use here is s equal to vt. So this is your s, this is the v along y-axis, and this is the time along y-axis. So this is the time of motion along y-axis. From theory, this is the time of motion along x-axis and this is the total time. That means swimmer has taken how much time to cross the river? He or she has taken this much time to cross the river. You can easily see, because sine theta is in the denominator, so higher the value of sine theta, the lesser will be the time. What is the highest possible value of sine theta? It is 1. And at what angle sine theta becomes 1? It becomes 1 at theta equal to 90 degree. So this means minimum time to cross the river will only happen if the swimmer swims perpendicular to the river bank. So theta is 90. In that case, you get the minimum time as d by vmw. Okay. Now, remember, in case of projectile motion, the distance that the projectile is to go along x-axis, we used to call it range. In case of swimming, this distance, this x, is called drift. So what is the x? The x is this much length. Okay. Now, how to get this x? The time of motion along x-axis is how much? This value. What is the velocity along x-axis? This is this value. Okay. So what is the value of the x? The value of x is, we are going to use s equal to vt. What is the v along x-axis? It is vw plus vmw cos theta multiplied with this time. That time is d by vmw sine theta. So this is the drift of the swimmer. Okay. Now suppose the swimmer wants to go for zero drift. The swimmer does not want x to be there. The swimmer wants the x to be 0. If x is 0, that means it is the equation of y-axis. That means the swimmer is going in this direction. So the Vm must be in this direction. So how to do that? So I'll erase this part and let us go for zero drift case. So for zero drift, the swimmer Vm must be along y-axis. So if this is the river width and this is say d, so Vm must be along the y-axis. And how it is possible to be Vm in this direction? It is only possible if Vmw is in this direction. So the resultant of Vmw and Vw is Vm, right? And the swimmer now goes in this direction. This is the y-axis with zero drift. So whenever the swimmer reaches the other bank, what will be the coordinate? Because drift is 0, y coordinate will be d. So what is the time the swimmer has taken now? The time the swimmer has taken is d by Vm. From Pythagoras theorem, it is Vmw and it is Vw. You can see it's a right angle triangle because Vm is parallel to y-axis. That means this angle is obviously 90 degree. So this means this is also 90 degree. So this is a right angle triangle. So from Pythagoras theorem, what will be the value of Vm? The value of Vm will be d divided by root under Vmw square minus Vw square, right? This is the time to cross the river in case of zero drift. And for this to be possible, see this equation, the Vw square that you are getting must be less than Vmw square. Then and only then this time is going to be real. Let me erase this x. This was representing the x-axis. So this is basically possible if Vw is less than Vmw. So for this equation or for zero drift, please remember this is only possible if velocity of man in still water is greater than velocity of water. Now suppose if Vw is greater than Vmw, in that situation zero drift is not possible. In that case what you have to do is that you can minimize the drift but you cannot have zero drift. There will be drift but you can obviously minimize it. How to do that? To do that, what you have to do is write the drift equation. I have written it a few minutes back. I hope you remember. What is the x-axis velocity? It was the river water velocity Vw plus the swimmer's x-axis component which was Vmw cos theta. What is the time to cross the river? It was d by Vmw sine theta, right? and this was the time along x-axis. So if you multiply the time with velocity using the formula A is equal to vt, because there is no acceleration here, you get the drift. So what you can do here, keep the d by vmw outside, take the sine theta within the bracket. So this comes as vw, 1 by sine means cosec theta, and here you are getting vmw cot theta, right? Now to get the drift to be least, remember in this situation you will have drift, because in this situation the river water velocity is much higher, or at least not much higher, it is higher than vmw. So I'll erase this part. You just have to do what? To get minimum drift, use the concept of maxima and minima. How to do that? Take a derivative of this with respect to theta and equate it to 0. That's it. That will give you the angle. So what I'm going to get? D by vmw will be outside, constant. What I'm going to get? Vw. What is the derivative of cosec theta? It is minus cosec theta into cot theta, right? And vmw, what is the derivative of cot theta? It is minus vmw cosec square theta is equal to 0. So what I can do here, see, cot means cos by sine, but cos by sine, that means 1 by sine is cosec. So this cot, this t, cot will become cos by sine, and I can write this as cos theta, and 1 by sine is cosec. So this will become cosec square theta. So what I can see here is that d by vmw, take minus cosec square theta outside. So within first bracket, what term you are getting? You are getting vw cos theta plus vmw. This is equal to 0. Now for this product to be 0, possibility d equal to 0. So river width is 0. That is preposterous, absurd. Another is that vmw is infinity. If denominator becomes infinity, the fraction becomes 0. That is also not possible, because speed has a higher, and infinite velocity is not possible, because speed has a higher limit, which is velocity of light. Cosec square theta is always greater than 1 or less than 1. Cosec square theta equal to 0 is not possible. So there is only one possibility, that this first bracket term is equal to 0. So if I equate this term to 0, I can easily see what is the value of cos theta. The value of cos theta that I am getting is minus vmw divided by vw. So the swimmer must swim at an angle theta equal to how much? Cos inverse of that value. So the swimmer must swim with respect to river bank at an angle cos inverse minus vmw by vw. You can memorize this answer. So if the swimmer swims at this angle with respect to the river bank, the swimmer will have a minimum drift. Remember, the drift will be there. Drift is not going to be 0, but that drift will be minimum, will be least. And at this angle it is possible. And because cos theta is negative, that means this theta is not acute, this theta is obtuse. So how the diagram will look like? So because theta is obtuse, how the diagram will look like? So the diagram will look like something like this. So suppose if this is the river banks, theta is obtuse, that means the vmw is here at this angle theta, vmw, and this value of theta is here. So the vw is much greater. So vw is now here. The resultant of vmw and vw will be vm. So the man will now go in this direction, and here, so this is the y-axis, this is going to be the drift. And how to find this value of x? We know cos theta, we can get the sin theta. In the drift formula, if you put the value of cos theta and sin theta, we can get this drift. I hope that this short discussion of relative velocity is helpful to you. I tried to integrate as much concepts as possible within this short period of time. In future, we'll discuss more such concepts and obviously some interesting numerical based on relative velocity. Thank you for watching. Tata. Like this video, share this video, and please subscribe to my channel. It helps me growing. Thank you. Tata. See you.